I have an idea. It's about chemistry and Pokemon. Pokemon's first generation, the red, blue, and yellow versions, is set in the Kanto region. It's also featured in some future generations, but that's besides the point. In this region, the town and city names have a theme. They're all colors or color-related. Here's a list of them in the order that you arrive at them in the games. I have procedures, papers, and ideas for the synthesis of all these colors, whether they be organic, inorganic, or metallic. This will be a series of videos, as it will take months to carry out. I'm open to input, and if I make multiple variations of any of these substances, I'll ask which y'all think is closest to the target color. Pewter is definitely going to be one of them, since I have a list of 15 different alloys of it that I intend to make small amounts of. Depending on how some of the other colors play out synthetically, I might need to seek out alternative options. I'll be trying to go in the order that the towns and cities are reached, but I expect at least one in particular to be very difficult, and I might have to postpone it and move on to the next one. Making a palette is the first part of the project. Since I have Pokémon's Blue and Yellow, as well as an original Game Boy Color, Game Boy Advance, and a Game Boy Advance SP, I'll be playing through Blue and including some clips of the towns, cities, and gyms from the game in these videos. I don't have Pokémon Red, so I can't complete the Pokédex, but thankfully this is a chemistry channel, not a gaming channel. I haven't been much of a gamer for years, but if by chance y'all are interested in me making gaming-related content for some reason, feel free to let me know. I'll try to make all of these substances from scratch one way or another within reason, and try to use the oldest known process again within reason. At least one exception is Seafoam Green, as it isn't a color that's derived from a specific pigment like most of the town names, so I'll have to improvise. Like I said, I have ideas for all of them, but Seafoam Green, Celadon, Lavender, and Fuchsia are the ones I anticipate running into some trouble. Maybe they'll all work out swimmingly, and I'm worried over nothing. Time will tell. In the concluding video of this series, I'll make oil paints out of all the products I synthesize by mulling them with raw linseed oil, and put small amounts of these paints on the palette. Again, I might have to improvise by making paints that aren't oil-based for a few, but we'll see. You'll all see. I have another idea of what to do with these paints, but that'll have to wait until the end. Firstly, let's talk about the palette. I could simply buy one, but what fun is that? A glass one would be optimal, since it's one of the least reactive of all materials used to make palettes. Plastics are common and are somewhat unreactive too. I decided to go with something more traditional and easy to work with. Maple. Pure maple wood would be ideal, but it's expensive and I haven't reached the point where I can make money from my channel. I'm thinking of making a Patreon, as many other chemistry channels have, because the ideas I have for videos are sometimes a bit costly and my expenditures have been adding up. For the palette, the best option for me is maple plywood. My dad has a Glowforge, which is a type of 3D laser printer, and there's a type of plywood designated for use with it, so that's what I got. It's a 1/4 inch thick and 12 inches by 20 inches, with an MDF core, and cost about 25 bucks. With the Glowforge, he was able to cut out a palette shape from the plywood using a template I found on Google Images. A practical artist's palette is a lot bigger than the one that was made for this project, but it's essentially a prop, so leave me alone. The remaining roughly foot square of material will be used for the idea I mentioned for another usage of the paints. Where the palette shape was cut, the edge is charred. Both sides of the plywood are coated with something slightly glossy, probably for protection of the wood surface. To clean up the scorch marks and remove the protective coating, I used a random orbital sander, a Dremel with a teeny sanding drum attachment for the tighter contours of the palette, and lastly, hand sanding. The random orbital sanding was surprisingly ineffective at removing the protective coating of the plywood surface, but it was great at removing the charred edges. Hand sanding was used for the surface, for the most part, and it worked well enough, but there were some scratch marks that I removed the best I could. I only removed the protective coating from the prettier side of the palette, as some of the scorch marks from the laser cutting were just too deep on one side and annoying to remove. The maple veneer is just that, a veneer, which is by definition thin, so if I had removed those scorch marks, I risked sanding through the maple veneer to the MDF core. After all this, I rinsed any residual sawdust off the exposed side of the palette with tap water and waited for it to fully dry. Once dry, I applied raw linseed oil to the raw side of the palette, waited for it to soak in, and wiped off the excess. Because it's maple plywood, the only part of it that's real maple is the veneer, so I figured 5 applications of oil was sufficient. This raw linseed oil treatment is intended to form a protective layer, as linseed oil is a drying oil that polymerizes upon exposure to oxygen. This polymerized protective layer should be a relatively inert barrier between the oil paints applied to the palette and the wood underneath them. An analogous but not completely similar application of this concept is the seasoning of cast iron. This seasoning protects the cast iron from water and other substances that might corrode it without it, and if applied properly, it forms a substantially non-stick surface on the cookware. Anyway, on to the video. Here is the starting maple plywood on top of the Glowforge. Here's the cutout of it. If you've watched Smiling Friends, you might see a coincidental resemblance to a main character of the show. At first, I thought the shiny appearance of the wood could have been just how maple looks, but I was wrong. Once I sanded a small sample section for a few minutes, I realized that there is most definitely a protective layer. After this, I fully scented and sanded the rest of the palette's prettier side. Once fully sanded, the application of the linseed oil makes the grain of the veneer pop. It's a double-edged sword, however, and it accentuates some of the unsightly scratches from sanding. It's not a commercial palette, it's for a pet project, and it looks good enough, so I didn't feel like spending more time sanding it. So, that's the palette. One thing down, a bunch more to go. Next stop, Viridian City. Viridian is a blue-green color between green and teal and is a hydrated chromium-3 oxide. Here's some info on its color coordinates if you're interested. Apparently, the original process for the preparation of Viridian from 1838 was highly guarded, so there's no record of it that I'm aware of. I'm using a process from 1859 where 3 parts of potassium dichromate and 8 parts of boric acid are mixed and calcined, a fancy word for heating something up, usually in a furnace where temperature control is important. I did it with propane torches and no temperature control, which kind of bites me in the ass for one of the attempts. I really should build a furnace, especially considering how Celadon is made. I have most, if not all, of the materials necessary to build one, I just haven't gotten around to it. The calcination of the mixture is supposed to be carried out at around 500 degrees Celsius for 6 hours. I think I spent about 15 minutes with propane torches, so the process is fairly robust, and these variations apparently aren't all that detrimental, unless you overheat it like I did in the last attempt. I recrystallized pottery-grade potassium dichromate from water to purify it. I made the boric acid by adding a slight excess of hydrochloric acid to a stirred, boiling, concentrated aqueous solution of borax. Once all the acid was added, I let the solution boil for about an hour longer, allowed it to cool, and filtered off the boric acid that precipitated. I washed the filter cake thoroughly with water to remove any residual sodium chloride. I did a super safe and scientific test for sodium chloride by tasting the boric acid. Boric acid isn't really toxic, especially in small amounts, so get over it. It didn't taste salty, really it didn't taste like anything, so I was satisfied that it was pure. I could have recrystallized it, but I didn't. This isn't analytical work, it's for pretty colors. I probably didn't even need to use the recrystallized potassium dichromate, but I needed some for analytical work and I recrystallized a bunch just to have it on hand. This is an inorganic reaction, so no mechanism. Some samples of Viridian that have been analyzed with XRD do contain boron, but others don't. It's thought that there's a chromium-3 borate intermediate in the reaction, but I don't know. The thermal decomposition of boric acid produces boron trioxide and water, and the thermal decomposition of potassium dichromate produces potassium chromate, chromium-3 oxide, and oxygen. I'm sure there's some weird-ass complex reactions going on, but I'm dumb when it comes to inorganic reactions that aren't being spoon-fed to me. The reaction mixture foams up upon heating, probably just due to the oxygen in the steam. It's pretty easy to separate the Viridian from the side products because they're all water-soluble. The test run went well, even though I didn't have the correct amounts. I just winged it because I hadn't found the quantities. The test run went well, but the second one didn't. The crucible cracked mid-heating and leaked, so some product was lost, but I managed to recover a good portion of it. The third run went worse, as I heated it too strongly and completely dehydrated whatever products were formed. This will be obvious once you see the resulting Viridian samples. Started by using my camp stove, pencil flame torch, and regular torch, but it was taking too long, and I remembered I had one of those weed burning torches. Not that kind. Anyway, I started blasting. I didn't overheat the mixture this second run, thankfully. Cold water was used to extract the product mixture, and I repeatedly washed and decanted the Viridian until the wash water was clear. The last wash water was distilled water, everything before that was tap water. The presence of potassium chromate is obvious, it's yellow, so if the supernatant liquid is yellow, it's present. It's easy to know when it's ready to filter as soon as it starts to clear up. The run where the crucible cracked, the materials didn't completely react, as can be seen by the orange coloration of the supernatant liquid. The filtration and washings take forever because the Viridian particles are so fine. Not too fine to pass through the filter, which would ruin my Buchner funnels. Afterwards, I tried to dry the Viridian by leaving it on the pump, but it just didn't work. It kind of developed cracks and wasn't evenly pulling air over it. I dried the resulting green goop in an air fryer at 220 degrees Fahrenheit or 104.4 degrees Celsius for an hour. The material doesn't dehydrate until it hits like 260 degrees Celsius, so I wasn't worried about the mild heating to remove the residual water. The third run was too far gone, even before treating with water, since I heated it so strongly. The heating was so excessive that the boron trioxide produced fused to the glaze of the handled crucible and chipped off when I was removing the Viridian from it. Only a small amount, but still, sucks. Because the degree of hydration of the chromium-3 oxide isn't well defined, I can't calculate a yield. In the trial run, from 10 grams of potassium dichromate and 15 grams of boric acid, I got 2.79 grams of Viridian. In the second run, I got 6.86 grams of Viridian, and in the third run, I got 7.69 grams of Viridian, but it's more likely that it's anhydrous chromium-3 oxide based on the color. I think run 2 is the best looking and closest to true Viridian. I only need a small amount to make a little dollop of oil paint for the palette, so what I got should be enough. And that's about all I've got. If you have any suggestions for future videos or in regard to this project, let me know in the comments. And other than that, if you want to, like, comment, and or subscribe, and I will see you in the next video.